Good morning, distinguished members of the practice community of air quality. I'd like to welcome you to the third technical session of CanAIRy Alert. I am Ana Cecilia Perales. I'm coordinator of CanAIRy Alert for WRI Mexico, and I'm very happy that we're all gathered here in this space. And as for the third session today, performance evaluation, our goal is to discuss the importance of the experiences and the performance of the air quality monitoring model, and talking about the experience of some Latin American cities that are part of CanAIRy Alert. We'll also be hearing about an initiative that works on data gathering to generate air quality forecasts for some cities in Africa. And now I give the floor to Emma Nolan, who is one of the first researchers of the GEOS CF, which is the NASA air quality monitoring model. Go ahead, Emma, take it away.
Thank you so much for the invitation to talk today. My name is Emma Noland, and I am a research scientist at Morgan State University, and I actually work physically at NASA Goddard Space Flight Center in the Global Modeling and Assimilation Office, based just outside Washington, D.C. So people often ask, why is NASA producing air quality forecasts? And that's because the Global Modeling Assimilation Office, or GMAO, our core mission is to enhance the value of NASA's observations to understand, analyze, and predict changes in the physics, the chemistry, and the biology of the entire Earth system. And we do this by developing and maintaining the Earth system model called GEOS, which stands for the Goddard Earth Observing System. So as the name says, it's designed mainly to advance the use of satellite data products. So we get global coverage from space of many different pollutants, but the temporal frequency for global coverage can sometimes be on the order of several days, not hours, depending on the instrument. So GMAO, we specialize in what's called data assimilation, and that's a process where we combine observations and models together using governing equations of physics within a model. And this is an image of an animation which shows our flagship model, which has simple chemistry for aerosols. And so satellite data can provide information of fire locations. And so you can see that by the red dots in South America. And then as these aerosols or particles are emitted into the atmosphere from both man-made anthropogenic sources and natural sources like fires, these are then transported. And so you can see the dust in orange coming off of the Sahara from Africa being transported across the Atlantic. We can see sea salt, especially in the southern hemisphere, being wrapped up in weather systems. We can see organic and black carbon and green coming off South America associated with those fires, biomass burning. And then we also have sulfate in white from anthropogenic sources, which you can kind of see over North America. But we wanted to expand the capabilities of our GEOS model to be able to provide atmospheric composition forecasts. So we run a coupled version of GEOS weather forecasting model with a very sophisticated chemistry model known as GEOS Chem. And this has over 250 species and over 700 chemical reactions. And we've been running this model since September of 2019. And it's the first of GMAO's near real-time products, which focuses on full atmospheric composition. So both the aerosols and the trace gases. And so on this next slide, I have two snapshots from an animation which illustrates how complex ozone chemistry is. And we need a sophisticated model like GEOS Chem in order to get the full diurnal cycle of surface ozone, which you can see in the top right with high concentrations in white during the day, close to urban centers and near forest fires. And while at night, like maybe in China on the far right-hand side, ozone is very low due to NOx titration. The bottom left actually shows 96 different chemical species that directly or indirectly impact ozone. And so you can see interactions with large-scale weather systems, as well as some of these emission sources, like the third one from the left. You can sometimes even see those ship tracks in some of these. And so it's really important that we're able to capture all of this in our model for realistic estimates of ozone and PM 2.5. So each afternoon, we start running the GeoCF model. We run the previous 24 hours with the GEOS coupled to GEOS Chem in order to have the best initial conditions for our 5-day forecast. We run the model at one of the highest spatial resolutions of a global composition forecast system at about 25-kilometer resolution. And this is from the surface all the way up into the lower mesosphere. So we also get like the stratospheric ozone hole correctly as well. The GeoCF, it's run on our supercomputer at NASA Goddard. It uses the equivalent compute power of about 3,500 personal computers, and it still takes about 8 to 9 hours to complete. And we provide both meteorology and chemistry at very high temporal resolution. So some as frequently as 15 minutes are available to the public, but most of our diagnostics are hourly. And this remains public for several years to allow research and other applications, such as the one we're going to talk about today. It's important to note that NASA GMAO products, they're designed to be research products and to support many different NASA activities, such as satellites and other ground-based instruments, which measure in the full atmosphere. So GeoCF is not optimized for surface air quality. But what we see is that GeoCF has been used to create many different value-added products because its capabilities and its public access. And so here are 2 examples of it being used on non-NASA platforms. One is in the left-hand side is sort of the Center for Disease Control in the US, which uses GeoCF to show daily air quality index values. As well as we've had a long-standing relationship with WRI. They were one of the first to create a value-added product based on GeoCF, and they shared daily global forecast maps. I'm going to go through the next 3 slides pretty quickly. I really just wanted the take-home message to show that we've evaluated GeoCF and found there's generally good agreement for the evaluation period of 2018 to 2019, but we also have some notable differences. Next slide. In the case for ozone, shown here as well as on the next slide, we can see that it's biased, not always biased low. Sometimes it's biased high. It depends on the region. And then on the following slide, we show comparisons to PM 2.5 surface observations. We pulled in some observations using the OpenAQ data portal, which provides observations on one platform, but they're grabbed in near real time. So they're not quality checked or have any quality assurance on them, but they're available on the platform. For PM 2.5, we generally see it overestimates the aerosols, and we understand why. We used an outdated anthropogenic emission inventory, as well as our biomass burning emission scale factors were tuned for a different model. And we have a new version that's going to be coming out later this year for GeoCF, and those have been fixed. What we're here to talk about today is the forecast skill. And one of the things that we found is that there was very little variation in our forecast skill from day -1, which is that 24-hour replay, before we launch our 5-day forecast. And the stars indicate the design value we want for these metrics across the 3 differences. One of the things we realized is that the forecasts were mainly driven by changes in meteorology. And so So mostly transport of the pollutants was a big factor. And also one of the issues is that we have rather large grid boxes. So the yellow box and the blue box show the GeoCF grid boxes, and the red dots are indications of monitoring stations in León, Mexico, which is the northwest of Mexico City. And we're going to focus on the blue box where these 2 monitoring stations are capturing the GeoCF. So Christoph Keller, who is one of the lead scientists with the GeoCF model, who has recently moved to a new position back home in Switzerland, developed a technique using machine learning to bias correct the GeoCF forecasts to these individual locations. And so on the right-hand side, the black line are the observations, and so those are different between the two stations, whereas the purple line, the model, is the same for both. And so we don't expect the pink to necessarily match these point sources. And so using a machine learning method, there are different input features are fed into a machine learning algorithm, which includes meteorology and chemistry for many different chemical species, not just the targets, as well as calendar information about hour of day, the weekday, and the month of year. We don't forecast the emissions, and so that's not used in this machine learning. But since the model biases are often site-specific, especially for that representation error, separate machine learning models are trained for each individual site. And so the bias correction factor, that difference between the observations and the model, along with the original GeoCF output, now captures the diurnal variability of ozone at the subgrid scale. So now we can see that the green, which is that model plus the bias correction, agrees really well with the observations. And so this was done for all of those different monitoring stations that was used in this analysis. And when we compare to the original scale scores in diamonds, we can see that the bias corrected forecast skill, as the box and whisker plots, now greatly improves over the original model forecast. You can see how it's much closer to the levels of where the stars are indicated. But these tailored forecasts, they're only as good as the training data that they see. So as shown here is an example of the machine learning algorithm, now in red, which was trained on the business as usual conditions prior to the pandemic in 2020. And you can see it did not predict those lower pollution values in black as a result of the reduced emissions during the pandemic. And so the City AQ project, which started a few years ago, following the collaboration between GMAO and WRI, we worked together to provide these bias-corrected forecasts for the first cohort of cities in Central and South America. These were provided on Resource Watch so that they became more easily accessible and easily visualized for air quality managers. So CanAIRy Alerts, they built on that City AQ project. So not only with a growing number of cities in the Global South, but also accommodate cities which have low-cost sensors only, not just the regulatory grade monitors. And so another thing to note is that CanAIRy first performed the quality assurance, quality checks on these low-cost sensor data before sending it to GMAO, to Christoph Keller. And we encourage more cities to make their data open and to join this initiative. And furthermore, WRI is developing this air quality interface to help air quality managers interpret the air quality forecast information for decision making. And so this is showing us the snapshot of that CanAIRy Alert forecast tool. And so as I said before, the machine learning model, it's only as good as the training data it sees. So as time moves away from the period of the training data, the performance of the machine learning bias correction method may drift as well. So this can require retraining for the machine learning for optimal tailored forecasts. And so if on the next slide, which I think is my last one, we're actively developing the machine learning algorithm to produce these bias corrected forecasts on demand. And so this will be done on the cloud, and then end users can upload their data and train the machine learning on the cloud. So we're very excited about this new development. And so thank you so much for your time and your listening. I can't wait to see Kasaya's analysis of the forecasts. Thank you.
Thank you very much, Emma, and thank you for being so punctual and for your presentation. Now I will give the microphone to Kezia Reynoso, Air Quality Consultant for WRI, who will present the results of the performance evaluation for the cities that are part of CanAIRy Alert: Monterey, Bogotá, Kampala, and Nairobi. Good morning, everyone. It's a great pleasure to be here with you. Today, I will talk about the results of the work that I've been doing with the WRI for evaluation of the bias-corrected forecasts for CanAIRy Alert. In general terms, forecasts are valuable tools for making informed decisions about observations over time. For instance, in air pollution forecasts, in air pollution, forecasts can alert about critical events during various periods, aiding people in avoiding pollution exposure. So it is very important to evaluate these forecasts so that we can guarantee their accuracy, identify their errors, improve models, and to support strategic decisions in response to climate change. So the objective of this work, the objective is to design a protocol for evaluating CanAIRy Alert bias-corrected forecasts based on a literature review and to evaluate the performance model for 4 cities: Bogotá, Nairobi, Monterrey, and Kampala. Thank you. Okay, so as for the methodology, what did we do? First of all, we collected the data. This was requested to WRI coordinators in Bogotá and Monterrey, and on the other hand, in Kampala and Nairobi. We requested information for 2 years. This was based on the literature, so we found that the results of the evaluation required at least 2 years of data to be able to prevent bias from the stations. So, and at the same time, we used an API so that we could get forecast data directly from NASA, okay, historical data for the 4 cities for the same years, 2022, 2023. So once we had the data, we made a script in Python, and we used that script to clean and order the data coming from the stations. So to this point, it's important to say that we had data from different cities, and it was coming in different formats, and this is why it was so important for everything to be standardized, to have them all in the same format. Once the data were ordered, we created tables where we had both data, so the forecasts and the data from the cities, and then we could perform a clear, concise evaluation. Then we chose the metrics. As I said before, this was based on a review of the literature, where we found a group of metrics that I'll be talking about later on. And once we had the data, we compared the data with the basic metrics and with the time series, and then we calculated the metrics of the chosen group, and we created a classification criteria. This we did in order to define the performance of the model in each city by station. Within the metrics that we use for evaluating air quality forecast models, there are different groups. We do this because a single metric cannot give us the full picture, all the information. So we need groups of metrics so that we can make this evaluation more robust. Within the group that we chose, we have these 4 main ones. We had chosen 6 indications initially, but the idea of this evaluation is that for the people who are in charge of monitoring networks in each of the cities, they could be capable of evaluating their own performance in their own city. So we chose only these 4 metrics, which are in a way simpler. They're easier to calculate, and they allow us to get a good, robust read on their performance. So these metrics are factor 2, which allows us to enter the values that are closest to the observations, and This allows us to see general trends, but it also allows us to observe the precision, as it were, or basically how the model is behaving. We also have two metrics that speak about errors, mean absolute error and the rooting square error. These two allow us to see the variability in our data. And then we have another bias, the mean bias, which allows us to see the difference between our observed data and our forecasted data. So once we choose these metrics, once we chose them, rather, we were able to establish criteria, which is based also on the literature review, and it allowed us to choose the values for each of the different metrics, and it allowed us to recognize the behavior. So on the left-hand side, you can see the values for each of the metrics, and based on the values, they are classified as excellent, good, acceptable, and poor. Once we have established this criterion, we choose a points-based system. So each metric gets assigned a point depending on the performance that we found. Excellent, 3 points, good, 2 points, acceptable, 1 point, and poor, no points. Then the final classification, we get that by adding all of the points in on all of the different metrics for the performance per station. If the performance is excellent, this means that the model is highly reliable and precise, and that it allows us to make critical decisions, and you can use it for detailed analysis. In this case, the accuracy and the precision are high. That is, we have forecasts that are very close to the observed values, and we have low bias. And there's low variability in errors, which is consistent with the predictions. Moving on, good performance means that the model is reliable, and it also allows us to make decisions, and it's suitable for most applications, although in this case, there is room for improvement. The precision and the accuracy are good in this case. The predictions are usually close to the observed values with moderate bias. And there's variability in errors, which is acceptable, and predictions are relatively consistent. Now, as for acceptable performance, that means that the model can be used for general analysis and for preliminary decision making, but it is not suitable for applications that require a high level of precision. In this case, accuracy and precision are moderate. And finally, poor performance. In this case, a model is unreliable and it should not be used for important decision making. And of course, this indicates that there are significant improvements needed. So now I'm going to show you the results that we got from the evaluation. This is for the evaluation in the city of Bogotá for PM 2.5. On the left-hand side, you can see two tables. In the top, we have the results for Bogotá, where we can see that the overall performance is good. Then we also have the case of Monterrey, where in general overall performance is good as well. I'm showing the values here for each of the indicators, and if we add up all the points, we get performance at each station that was evaluated. On the right-hand side, you'll see two graphs. At the top, we can see the results for the High Performance Center in Bogotá 2022. The figure shows in red the real data and in gray the forecast data. And you'll see them for each day of the week over the daytime. So we can see in this case that in this high performance center in Bogotá, the forecast follows the general trend of the data, but it's not precise in the peak values. However, yes, there's an underestimation of the data across the days of the week. And by the end of the week, on Sunday, there's an overestimation of the data. So these are, of course, important details that this evaluation has showed us for each of the cities, right? So even though the trend in general is towards forecast data being close to real data, we can see these discrepancies, as Emma Nolan said before, actually. So there is some differences, and of course, the model needs to be retrained over and over again. In the bottom right figure, we have the data for the station at Obispado, Monterrey. We also see overestimation of the forecast compared to real data. However, in these two cities, sorry, an underestimation, but in these two cities, the general performance is good, as you can see. Next slide, please. I'm showing you the results for PM 2.5 in Kampala and Nairobi. In both cases, the overall performance was deemed acceptable. And well, we did find pretty large variability in the data as revealed by the MAE and RMSE metrics. So you'll observe that FAC2 in general is good or even excellent, which means that the forecast does follow the general trends, as we can see in the graphs on the right. This is true in both cases. So in both cases, the forecast is able to capture these general tendencies. However, not the peaks, not the peaks values that we have found. And these errors show us that there's very significant differences. So in the case of the top right, we have the US Embassy station in Kampala, and in the lower right, we have data from the Nairobi station. These results are very interesting. Again, we see on Sunday the model overestimates the real PM 2.5 data. Here, we have the NO2 results for Bogotá and Monterrey. In the first case, we have an overall performance that is good. Again, the general trends are being followed, as you can see in the graph on the right. This is for a station in Bogotá, which is a high-performance center station. That one in particular has excellent excellent performance. And in the bottom, we can see results for the Obispado station with acceptable performance. So in this case, there's an underestimation, a pretty significant underestimation of the data of this pollutant NO2 in Monterrey. Finally, we have some results for ozone. Here we found that the overall performance in Bogotá is acceptable, whereas in Monterrey it's good. Again, the general trends are followed, as you can see. But for the case of Bogotá, as I said before, the forecast is not accurate, it's not precise, even though it does predict the general trends of these pollutants. Conclusions. In Bogotá, the model demonstrates a good ability to track general trends in these pollutants with a notable capacity to capture PM 2.5 and NO2.
Los picos de altas concentraciones de PM2.5 y dióxido de nitrógeno. De igual manera, en Monterrey.
Now, similarly, in Monterrey, the model also tracks general trends and it exhibits improved accuracy for detecting peaks of PM 2.5 and ozone. This shows the capacity of the models to predict high pollution in both cities. In Kampala, the model is rated as acceptable for PM 2.5, indicating its ability to track general trends and to provide alerts for high pollution episodes. However, it struggles with accuracy in predicting high-value peaks and rapid variations in air pollution. And finally, in Nairobi, the model shows a capacity to track general trends and issue alerts for high pollution episodes, but it faces challenges in accuracy and precision. That's it for me. Thank you very much. Thank you so much, Kezia. Now I give the floor to Betty, who will help us moderate this first round of discussion with our panelists. That is Emma and Kezia.
And I will start, and while we have our participants to ask some questions, I think I will go with the first question to Emma. Emma, thank you so much for the presentation. I think it's just wonderful to know, I mean, all the road as well as the plans that you have. Can you expand a bit on the plans? I mean, you have identified what are the what was the potential for the GOCF, and then how this potential increase in terms of being used by the city or by any other stakeholder, right? And you also mentioned that you have some plans, like the next version. Could you expand on what will be that new version? I mean, with the Kezia, we saw that even the current version is very good in predicting some of the trends, and I will go later with Kezia, but can you expand of what have you learned on how this the GOCF could be improved, and what are the plans?
Wonderful. Thank you so much for that question, Beatrice. Yes, so we've been running this same model version now for many years. Our weather forecasting model is updated every 6 to 12 months, and we wanted a stable version of the model so we could evaluate it, as well as a lot of these applications need a stable model for something like machine learning so that you can train the model over a long period without the model changing and impacting those results. But over time, we've realized that there's lots of little things that we could do to improve the performance as well as diagnostics for end users. And one of those that's coming online in this new version is going to be PM10. So we only had PM2.5 before, but now we'll have PM10 as well, so we can target that in the forecasts. We don't have data assimilation for the constituents, so like NO2, nitrogen dioxide, ozone, SO2, those we will now incorporate that into the analysis. So we have the best initial conditions for the forecast. So that will help bias correct in the underlying model some of those features that impact the air quality. The resolution is going to stay the same right now, but in future versions, we're looking to have higher resolution both vertically and horizontally. But we're also updating the emissions, so they'll have the anthropogenic emissions will be up to date through 2019, if not newer, and that drastically improves the PM2.5, and we have new scale factors for the biomass burning, which drastically improves the PM2.5. So it's still a work in process. We're only going to have 2023 onward, so that's something that we need to consider when it comes to this project here to support the CanAIRy, is that we will be looking to retrain the models with newer observations, which hopefully will also help with any potential drift in the machine learning bias corrections if they were trained on data, observation data pre-pandemic. We've also realized that the machine learning backend from our side, it grew with the project. And so in itself, we've realized there's lots of little pieces that need to be reconnected with Christoph Keller's departure. And so we're actively working on how do we make that not linked to one person, but linked to our office. And so we are currently integrating that. So my sincere apologies that the forecast has been a little bit stop and go since May, but we are actively working on that because we really want to support our stakeholders and users around the world. That's been our goal from the very beginning. We've devised GeoCF with conversations with WRI and many other stakeholders from the beginning. So hopefully that helps answer your question. Thank you.
It does, and I also would like to take this opportunity to thank all your team and all the support. I mean, this is the web app that we are using. The CanAIRy Alert is only possible if we have the collaboration with you, and of course the collaboration with the cities who are not only the data provider for the users. So thank you so much. Very, very exciting. We have a question also for Joe Maniki. For you, Emma, and this question is: how often should the bias correction tool be updated? And this is to reduce time bias, based bias. I mean, what would be your recommendation of retrain the model?
Yeah, I think that would definitely depend on the analysis, like what was presented today, that shows how well the bias correction is performing. I would say as long as the data that's provided, I think we, at least a year to 2 years is really the goal, so you can cover the breadth of environmental changes, seasonal changes. How different is your environment during an El Nino versus a La Nina? If you capture that in 1 year and it's very unique, you don't necessarily want that to be persisted into the future. And so keeping that in mind, just how our daily lives change, we probably don't want to train it on 2020 during COVID, things like that. So our GeoCF underlying model does not get updated that frequently, but we are in constant conversation with Beatrice and the team here at WRI regarding our updates. And so we will be looking to make the switch later this year. So we will need to make sure that this continues into the future.
Thank you, Emma. And one question that we have gotten recently is we know that the GeoCF also produce temperature precipitation as part of the forecast. And particularly the last couple of months, we are all experiencing these heat waves. So yes. One question is, would be you think about considering the forecast for temperature and maybe do an evaluation, because some of the monitoring stations are also generating data from meteorological stations. So do you have anything in mind, or what do you think about, in addition to the criteria pollutants that everyone is so aware of and they want to know in advance so you can take actions? What do you think about temperature? Thank you.
Yes, the GEOS weather model forecast is run 4 times a day. So there are more frequent weather forecasts. We do 1 5-day forecast, 1 10-day forecast, and then 2 shorter forecasts. So that's the state of the science for us. It's available that we could look into that and you could do an analysis of it. But as I said, that model does get updated frequently. We're looking at another big update coming down the line soon. If you needed something more stable, the nice thing about GeoCF is that we produce the meteorology and the chemistry on the same spatial and temporal scale. So you can get temperature, humidity, precipitation, things like that, alongside the ozone, the NO2, the PM2.5, the soon-to-be PM10, CO, SO2, like all of that. And that's actually one of the nice features of GeoCF, is having those publicly available together globally. That's not something that you necessarily get from other composition forecasts.
Great, thank you, Emma. And we have a question also for Ketia. I will just like to say that, as Emma mentioned, we were very happy to have access, to be able to have access to the bias-corrected forecast since last year for 4 cities in Africa, in addition to Addis, who was already the platform, as well as the Latin American cities that we had before. And one of the questions that we have had over the time is like, okay, now we have at least 2 years of the bias corrected forecast being produced, being used. And so can we take a look of how well the performance of the model, what is the performance of the model if we compare over the last 2 years of data being measured in the monitoring station versus the forecast model. And that's where Kezia's collaboration came to CanAIRy Alert. So she has, as she described, been working on these 4 cities. And I think it's very interesting what we have learned. So there is one question for Kezia. Oh my gosh, there is the question. So the question that we have for you, Kezia, and then I add to her, is did you notice any difference in the model based on the instruments? Like the performance of the model based on the instrument that we use to collect the data. This is the reference monitoring data versus the locus, which was a question in the previous stage, right? We knew that we can use data from reference monitoring station to train the model and get. So the big question is, what about other cities that only local sensor data is there? And particularly, we know that there is some quality assurance, quality control, and in other cases there is not. So did you notice any difference in terms of the performance of the model? Kezia?
Bueno, sí hay una diferencia que se puede observar en los datos.
There is a
Y
difference that we
esto
can
se
observe in the
aprecia en la
data,
variabilidad de ellos.
and we can appreciate that in their variability.
Pude resaltar cuando mostré
As I was able
indicadores
to highlight when
que
I showed
mostraban el
the
desempeño
indicators
en
for
las ciudades, por ejemplo,
performance
Kampala
in
y
like
Nairobi.
the cities of, say,
La mayoría
Kampala
de
and
estos
Nairobi,
sensores son sensores
most
de
of these
bajo costo.
sensors are low-cost
Entonces, esto nos
sensors.
muestra valores de las
So
métricas de
this shows us
errores
values
mucho
of
más
the
grandes.
metrics
Esto
that
tiene
have a lot
sentido
more
cuando
errors,
nos damos
which
cuenta
of
de que
course
son
makes
sensores de
sense
bajo costo y por supuesto la
because these are
variabilidad
low-cost
aumenta
sensors, and of course the
muchísimo.
variability
Entonces,
changes a lot, it
inicialmente
increases a
habíamos
lot.
establecido un criterio
So initially
para
we established
estaciones de
some
referencia y
criterion
otro para
for
los
reference stations
sensores
and
de bajo
another
costo.
one for low-cost
Porque nos
sensors,
damos cuenta de que
because we
sí
realized
hay una diferencia en
that
los
there
datos.
is a
Sin
difference in the
embargo,
data.
decidimos
However,
tener un solo
we
criterio para
decided
ambos
to
y
have the same
claro,
criterion for
cuando
both
los
of them in
sensores
the
de
end.
costo son
So of course,
calibrados
when low-cost sensors are calibrated
adecuadamente,
correctly and
se les lleva a cabo un proceso de calibración y de ajuste.
yeah, when they are
Entonces
calibrated,
podemos
when they
llegar
are
a
adjusted, when they
un-
undergo this
a
process,
momentos en donde
then
se pueden
we can
comparar con los datos de la
actually compare it
estación de referencia.
with data from a
Entonces,
reference
sí se
station.
puede observar en los
So
datos, es
yes,
muy
we
claro,
can
en cuanto
observe
a
the
la
data
variabilidad de ellos.
in terms of their
Eso es
variability.
todo. Gracias.
And Kezia, I think that you have also, I mean, you mentioned the importance, and as well as Emma, of the data that we are using either to train the model first and then to evaluate. What is your experience or and I would say your recommendations? I mean, what we want is that the cities, no matter what stage they are able to use their quality forecast and what type of data they have. So we know since the beginning that the data availability, probably the quality assurance, quality control is not the same. Still, as you show, cities can use the bias corrected model, right? Particularly knowing that they are what are the characteristics that they will see for the prediction. What will be your recommendations in terms of the data to be shared by cities? You mentioned that one of the challenges you have was formatting the data, right? So do you have any ideas how to standardize the format of the data that we are asking the cities to share, first to train the model and later to evaluate the performance? And again, considering that not all the cities are in the same stage, they have different capabilities, different possibilities. Would you give some recommendations of what have you learned from this process?
Claro.
Of course,
Algo que fue una sorpresa fue la importancia de los datos. Ya lo sabíamos
One
desde
thing that was
antes,
a
pero en este
surprise was the
proceso ha sido
importance of data.
muy
Of
claro
course, we knew it
que
beforehand, but it's been
la
made
calidad de los
patently
datos,
clear
como
in
en
this
algún
process.
momento Emma
So
mencionó,
the quality
el
of the
modelo
data,
se
which is
entrena
something
con
that
estos
Emma
datos.
touched on as
Entonces,
well. Well, the model
mientras
is trained
mejores
on these
datos
data. So
tengamos,
the better the data you
mejor va a
have,
ser
the
el
better
entrenamiento del modelo.
the
Esa
training
es
of the
la
model,
primera
obviously.
cuestión.
That's the
La
first thing.
segunda es que cuando hacemos una evaluación,
The second thing is that when we do
necesitamos
an
tener
evaluation,
los datos de manera
we need to
que
have the
podamos compararlos
data
con los que nos
in such a
proporciona
way that we can
el
compare it
pronóstico de la NASA.
with what the
Entonces,
NASA
digamos
forecast
que queremos que
provided.
los datos hablen el mismo idioma.
So basically, we want
Para
the data
esto,
to
la
speak the same
recomendación
language,
es
so to speak.
que tengan
For
un
this,
formato
the
específico,
recommendation is to
una
have a
recomendación que se ha
specific
generado a
format.
partir de
This is
de
a
este trabajo.
recommendation that has stemmed from
¿Cuál es
this
el
work,
formato que
right?
deben
So,
tener?
and what is the
¿Cuáles son los
format?
datos que podemos utilizar?
What is the right
Para que
format? What
podamos
is the data
comparar
that we can use
datos y para que
so that
podamos
we
hacer
can
una
actually
evaluación.
compare the data and we
Durante
can
este
actually
proceso, los
evaluate the
scripts
performance?
que he
Over
generado
this
se
process,
van
the
a compartir
scripts
con
that I have
las personas
generated
de las ciudades.
will
Y
be
esto es
shared with the people
facilitarles
at the cities.
tanto la limpieza y el
We will
orden
do
de los
that to
datos
make it easier for
como
them to
para
clean
bajar los
data
datos
and
de
to
la
order
ciudad.
their data as
Entonces,
well as to
parte de
download
este
city
trabajo es
data.
entrenar a
So
las
part of
personas
this work
que
is
están
to
en las
train the
ciudades
people who are
para
in the
que
cities
puedan hacer su
so
propia
that
evaluación y puedan
they can do their own
encontrar cuál es
evaluation
el desempeño
and
del
so that they
pronóstico
can
en su
find
ciudad
the
para
performance of the
periodos
forecast in
específicos.
their cities for
Entonces,
specific
creo que esta
periods.
parte ha sido
So
bastante interesante y nos ha
I do
dejado
think
muchas
this has been quite
enseñanzas en cuanto a la
interesting,
importancia de
and
la
we've had
calidad
a
de
lot
los
of
datos.
learnings
Entonces, no
about the
solamente es
importance of the
tener
quality of
datos
the data. So it's not just
durante el
about
tiempo
having
necesario
a
para
lot of
hacer una
data
evaluación,
over the
sino
necessary time.
además que estos
You
datos
also
tengan
have to
una
consider
calidad
the
mínima que al
quality
menos
of the
hemos
data. They
establecido
need a
un criterio
minimum
para
quality. We
poder
have actually
utilizar datos para la
established
evaluación.
a criteria for this so that the data can be used for the evaluation. Very much, Kezia. Thank you, Emma. Thank you, Betty, for this round of discussion and for your presentation. Now, we will move on to the second part of the session. We will have another round of discussion. And panelists, I remind you that you have approximately 5 minutes. So let's welcome Edison Ortiz, who coordinates the atmospheric modeling system at the District Secretariat of the Environment, Bogotá. We have Gerardo Argullín, Air Quality Agency from Nuevo León. We have Mónica Jaimes, Deputy Director of Analysis and Moderation in Mexico City, the Ministry of the Environment. And we also have Richard, I can't say your last name, sorry, but he's a data scientist in the ECO initiative. So thank you everybody for your time. And let's move on with the discussion then.
The first question goes to Edison. Edison will also would like to acknowledge all the support and all the collaboration we have had with you, and how important it has been to know from the experience from Bogota. We know that you have been using different air quality models, including the one, the GEOS CF bias corrected through CanAIRy Alert. So we would like to know if you can share with us when you are evaluating performance of your models or the example of your models, what methodologies or what methods have you used? And maybe if you can comment, what is the importance of doing these evaluations? And maybe what will be the recommendations for other cities based on the learnings from Bogotá?
Gracias, Betty, por tu pregunta.
Thank you for your question, Betty. So we use a lot of different models, both local models as well as global models, among them GeoCF, with and without machine learning bias correction. We normally evaluate in the short term, that is, we understand now that we need to make daily decisions based on these forecasts. And to that end, we basically evaluate daily or weekly the performance of the models so that we can make decisions. Mostly when we have some alert periods. So in this period, conditions are key for the cities, which means that we need a timely response for the alerts, for measures, for quality control. So we do have a forecast that has some good performance indicators. We have high reliability in terms of what will happen, and we can use the forecast tool as a kind of fundamental criterion for the exceptional alert states. Of course, there are cases where none of the models work, not even the global models. This is due to some strong effects by, for example, forest fires that are close to the city and some such events. This has made it very hard to forecast, and due to the low performance that we usually have when we don't include these events in our forecast models, well, this means that we can have low performance indicators in these cases. So we can't really use it in this case as a tool. What kinds of methodologies do we use? Well, besides the indicators that Kezia showed us before, we use the index of agreement and the coefficients of, oh, I forgot the name in English, but it's a coefficient for adjustment. It's more complicated mathematically, the calculation, because it gathers basically all of the indicators that Kezia showed us. And under certain numerical criteria, it allows us to know if the model works or not, especially in the short term. And as for the evaluation of the models here in Bogotá, they all generally work very well. Both our local models, as well as the GeoCF with machine learning, it works pretty well when certain conditions are met. What we have found is that if a model fails, if the GeoCF is not capable of reproducing it, for example, and we can't do it with our local models either, because we're talking about local forces that are generating this discrepancy in the observations. And this combination of global models and local models, on top of helping validate the data, it helps promote the local models as well, because there are some stations where the machine learning model is working relatively well, but our model isn't working so much in some cases. Well, this means that we need to look at our emissions inventory in that area. So this helps us look at what's going on with some of the sources in the areas, to try to understand that what we're doing is overestimating some of the sources, or on the other hand, perhaps we are underestimating some other sources. And well, my recommendation, to keep this short, my recommendation for other cities is that regardless of whether the monitoring stations are reference stations or low-cost stations, I believe that the most important thing for complementing the forecast with the observations is the location of the stations. So you need to comply with the micro localization criteria that are provided by the EPA guidelines, as well as the reference guidelines, and basically try to make it so that these stations are above the urban canopy, so that they can have broader vision, broader reach of the dynamics of the atmosphere, and not so much the microenvironments. This is what could be giving some errors, especially in the microsensors. So this is one of the reasons why the high performance center station in Bogota has had such good performance, especially with the global models, because that station is in the middle of a park. It's really a kind of grassland where it is. So the samples are quite above the urban canopy.
Entonces,
This
al
is so
ser pues
because
una
it's in a
corporación
grassland,
bastante bien,
so
porque al garantizar
I think
eso,
that is why it
las
works so
estaciones tienen
well,
una
because
capacidad, una
this
visión
means
más
that
amplia
the
de la
stations are going
atmósfera, es
to have
decir,
a
tienen
much
una cobertura
broader
más
vision of
amplia
the atmosphere. They
de
have larger
caracterización
coverage,
de la calidad del aire a la redonda. Y ya creo
and
que con eso respondería todas las
I
preguntas
think that
y
basically
les
answers all of the
agradezco por el
questions.
espacio.
Once again, I'd like to thank you for the time.
Thank you so much, Edison. I'm glad. It's, thank you for sharing also your experience. I think it's one of the reasons why we have this community of practice, is that we can use the experience from those cities and teams like yours who have been struggling for a while and finding and learning, and they can also share. So thank you so much. And thank you also for highlighting the importance of characterizing the monitoring station, and what type of what is the representativeness of this monitoring station, and if they can be used or no for the model to evaluate the performance. So this is very good. Thank you very much, Edison, and maybe there will be some questions, so be prepared. And we will continue. What we wanted to have in this panel is just, as we mentioned, the experience from the city managers, the air quality managers of different cities, and particularly the experience like when they are using air quality model forecast. We will continue with Gerardo are with me. He's from the, as Ceci mentioned, from Monterrey, from the Nuevo León Air Quality Agency. So Gerardo, you have also been one of the main users of the GEOS CF bias corrected model for the last 3 years. So we would like to hear from your experience. First is how the use of how are you using the air quality forecast to communicate to both to the general audience, but also to inform your decision makers? If you can also share what do you find about the evaluation performance, and what would you like to do in the future of how this, knowing now how the model is being performing for each of the modeling for the monitoring stations? Will that change in terms of communicating the results or what the model is telling? To thank and acknowledge all the collaboration that we have had over the last years with the Nuevo León Air Quality Agency. Thank you.
Okay. Muy buenos días, doctora Betty. Gracias por el espacio, la
morning,
invitación nuevamente.
everybody. Thank
Como
you
bien
for
lo
the
menciona,
invitation to
hemos
participate. And
hemos sido
as you
muy
mentioned,
activos dentro de esta
we have actually
colaboración
been very active
WRI
in this
desde hace
collaboration with
algunos
the
años.
WRI for some
Hemos
years
ido
now.
creciendo y
And
aprendiendo
we've been growing,
cómo
we've been
implementar
learning,
toda esta parte
and
de los
we understand better
pronósticos.
how to implement
Ha
the
sido
forecast
un
now. So
aprendizaje constante que hemos
this
ido
has
teniendo.
been
Hemos
a journey of constant learning.
generando o determinando áreas
And we
de
have been
oportunidad, y
generating or
hemos ido
spotting
trabajando
areas of
gracias al
opportunities that
trabajo
we've been working
conjunto
on.
con
And thanks to
con
joint work
WRI en el
with the
desarrollo de estos pronósticos
WRI
ha
in
permitido ir
developing these
mejorando, como ya
forecasts, we've been able to improve.
mencionaba Edison, lo mencionó Kesia,
As Edison mentioned, as Kesia
la parte
mentioned.
de la
So
calidad de la información en el monitoreo pues es una parte fundamental que nos
quality
ha dejado ver
information for this monitoring quality evaluation is all obviously very important. And this has been important to our work recently in terms of weather forecasting and other kinds. So we have been working. So let's say in the case of the city of Monterrey, we have 15 monitoring stations here. We originally started with 5 stations for this project, which in the moment, they were the ones who met the quality control criteria, those 5 stations. And well, we've made some progress, and We have been able to improve the forecast internally for our work teams, which I'd like to mention, because, I've had the opportunity of talking to environmental agencies in other states who also have monitoring stations, but they have smaller stations sometimes. So we invite them to approach us, to contact us, because this is a learning that should be for everyone. And it's not measured just by the number of stations. So if you have a monitoring station, please share your information and please start participating, because this is a community of learning, as others before me have said. And we have also been learning. We've learned about modeling, we've learned about forecasting, and as for how to communicate it, well, right now we have our air quality management program. This program involves a lot of industrial sectors. It involves citizens, it involves universities, people in academia, and basically we have been working with communication with the industrial sectors. And sometimes, as Kesia mentioned, sometimes you can underestimate or overestimate the peaks. This happens. And so sometimes, yes, we do have a bias, but this allows us to get ahead of any kind of situation that we could have in terms of critical levels of pollutants. It allows us to issue an alert for the industrial sectors that we've been working on. We have constant work and constant communication with them, and therefore we know 24, 48 hours beforehand that there's going to be more contamination because of our communication with them. And then all of the sectors, right, the municipal authorities, everybody has a function, everybody has a role to play, and everybody has some actions to take. And there's different programs integrated into the agency, and we have found that we haven't reached such high levels of pollution precisely because, well, there's been a reduction of emissions at the sources, industrial sources, or we also have everybody basically trying to do their best, making their best effort. And beforehand, we reached critical levels because we didn't have these kinds of tools. But now, thanks to these tools, we have seen a reduction in the levels of contamination. So we notice that these critical events are not as frequent as they used to be in the past. And I think the GMAO mentioned this, or NASA mentioned this, about one of the great problems that we have with PM10 that we heard is going to be integrated recently, which is great news for us, because we still have a lot of problems with this pollutant in the north of Mexico, PM10 that is. So this is going to be great. This is great news. And well, we'll keep working together with the WRI. We have learned a lot in this process. And again, if there's people here from other states in Mexico, I invite you to join this initiative. We need to keep learning. It's always a great pleasure to collaborate with Edison, of course, with Monica. It's always a pleasure to hear you all. The WRI experts, of course, always great to hear from you. And of course, there's a before and after forecasting in terms of air quality in Nuevo León, thanks to this. So, thanks.
Thank you so much, Gerardo. And I think that you gave a great description of how an air quality tool like this, the forecast, could help as you mentioned, just to inform, to communicate better with some stakeholders like the industry, civil society, and then authorities, local authorities can take decisions jointly with those sectors and reduce emissions, and then reduce this exacerbation of already bad days when different conditions are getting together. So I think this is a great description of how you have been used. And as you mentioned, we are learning a lot. And now that we have more monitoring stations and better data quality, then we hope that the bias record will be even of more use for you. Thank you very much, Gerardo, for sharing this with us. And I will continue. Another invite participant is Monica Jaimes, Dr. Monica Jaimes from Mexico City. Well, the Mexico City has been using a model for a while. They have their own air quality forecast model. We're very happy that they were very generous in sharing their data from the monitoring station. And then with that data, the GMO group was able to generate a bias corrected forecast. So that their quality forecast is now there for them. But we would like to hear from your experience from Mexico City experiences. Well, first, what methodologies or what do you do to evaluate the performance of the model that you have used? And then when you do these evaluations, how they are used in order to improve either the model or even to communicate better, maybe with a high-level official or with general community. What will be your experience? And maybe, yes, if you have some ideas that other cities can use based on your experience. We know that each city, as we mentioned, is in a different space. They have different capacity, different needs. But at the end, we all have many things in common. So we would like to hear from you. Thank you, Mike.
Muchas gracias por su invitación y
Thank you very much for the invitation. And in our experience,
empezamos a correr el modelo, decidimos desarrollar un
from when we
sistema de
started
modelos
running the model, we
interactivos
decided to
en el
develop
cual,
a modeling system.
prácticamente real en cuanto sale
And
el modelo,
basically,
en cuanto
almost in
toman
real
las
time,
decisiones,
as soon as a model outputs the
incluso,
data, we have the
en
simulation, we
cuanto
do the
está en la
evaluation.
salida,
In
se
fact,
aplican ciertos postprocesos para
we
mejorar
apply
y
some
ajustar el modelo.
post-processes
Uno de ellos es
to
el
adjust
filtro
a
de
model.
Kalman, que es uno de los mejores métodos
Once
para
is
tratar los datos,
one of these
sobre
is a
todo los
criterion that is
datos de
very
la
good for
noche,
adjusting the data,
ciertos
especially data from
contaminantes
the
como las
night about certain
partículas
pollutants,
o
as is the
SO2,
case for the
etcétera,
particles
que
or
nos
CO2, for
permite
example.
hacer un ajuste
This
casi
allows
perfecto,
us to have an almost
porque
perfect
nuestro modelo,
adjustment
esos datos
because
de la mañana y la
in
noche
our
no
model,
los
the data
detecta.
from the morning
Con
and
el
the
filtro
night,
de Kalman es uno de los mejores
we
métodos
didn't
para hacer ese
it
tipo de
didn't used to
ajustes.
work like
Entonces,
this way before we
desde
had
que
the
se
Kalman
estableció el
method,
modelo,
which is what it's
nosotros
called. So
aplicamos el filtro
ever
de
since
Kalman, que
we
era
have
nuestro primer
established the
ajuste.
model, we have used the Kalman
Y en el
method
sistema
control
de
as a first
modelación,
adjustment.
nosotros
And
evaluamos
in the
tanto las
modeling system, we
salidas
have
del filtro del
evaluated
ajuste de Kalman como las
the
salidas
outputs
sin
with
ningún
the
tipo de intervención.
Kalman adjustments and
Sin
the outputs
embargo,
without
sí
any kind of
tenemos
intervention as
otros
well.
problemas con los
However, we do
datos
have a lot of problems
altos.
with
Y es
high data,
normal y no solamente
which is normal,
ocurre en México y
and
en nuestros
it doesn't
países,
just happen
en
in
países
Mexico
como
or any
China,
of these countries. Countries like
tienen,
China, for
yo
example,
creo, una
who have
tecnología superior a la nuestra en cuanto
superior
a
technology compared to us, I
sensorización,
think,
en cuanto a Latinoamérica. Una
at least
vez les
compared
hice
to
la
Latin
pregunta que
America. So
también sus modelos
we once asked them
podían
how
pronosticar lo que
good
iba a
their
pasar porque
models
ellos
could
igual
could
que
forecast
todos
high data,
nosotros,
and they said
pues no,
the same
no
as
es
everybody.
tan fácil porque son
So,
datos
or rather, no, the
atípicos.
same as any other
Entonces, para
data,
que un
right? For them,
modelo
is the
pueda
thing. But that's
pronosticar
not the
un
case
dato
for us
atípico,
because
pues
these are
realmente
atypical data.
necesita
These
el
are
doble de infraestructura de
extraordinary data.
datos,
So, in order to
porque
forecast these atypical
ellos
values, you would need
continuamente están
NASA level
actualizando sus
infrastructure.
datos
It's very hard.
con las
They constantly
temperaturas,
update their data with
etcétera.
data
Entonces,
assimilation and so on.
tienen recursos de
So,
cómputo que casi
and
la
they have
última
computational
potencia.
resources that almost nobody
Entonces,
else has access to.
nosotros, al ver
So,
esto, nuestros autoridades o tomadores de decisión sí
our
nos
decision
exigieron un
makers
poco el que
they do demand from us that our model should be able to include these data. So we decided to include other metrics or other post-processes, which we call statistical methods based on modulation output. So we didn't just apply this filter, but also resistance methods, quantile mapping. We applied other kinds of models and have the gradient boosting machine, which is a machine learning algorithm, which helps us see how the model adjusts. However, due to our lack of computational resources, we can only apply the simplest methods. The analog method and the machine learning method, even though we want to, we haven't been able to include this model because of our lack of computational power, computing power. And at the CMAT, in the new stage, maybe the situation can be better because right now we are not running the forecast because we had to turn off the cluster because
de la dirección general, que incluía los verificentros y todo, se tuvo que mover de edificio.
We had to move buildings for some of the computational equipment, which is a long process. We are just about to acquire the new equipment, but once we get this new infrastructure, we will be able to run all of these methods once this is ready. Okay, now our general experience is that it is very important to evaluate the model every day. Why? Well, because this allows you to see with the different metrics which one is better adjusted. And this can enable you to give decision makers better information. Unfortunately, these outliers, it's very hard to handle them. Even if we run 3 models, there's one that in the ozone season gives us a better approximation, but we do have some questions about whether if we say that there's going to be high pollution tomorrow, for example, if we forecast that, how likely is it? Because the model tends to overestimate sometimes, so you can never be sure. But we're working on all of this, and we are willing to support whoever wants to. If they want to know how we carry out our evaluation, if they'd like to learn more about our experience, and if they require our help or they could use our assistance, of course. What we have used in the model that has been very helpful is, for example, in the last WRI that we did, I mean, never in the country had we done this before, that based on the control strategies that were proposed, there was an evaluation of what would happen. There was always just an approximation, but in the last WRI that was published, the model was used right now for diagnosis in this case, which included all of the strategies to be used and seeing what was going to happen in 2030. So this also allowed to evaluate the impact on health. And the model is a fantastic tool, and it helps decision makers. And it helps with the control strategies. We have also evaluated the impact of fires on air quality, and we have also developed an index. This was actually when Betty was part of the team. So we developed an index for vulnerable people. And this can only be generated with the model. Right now, we haven't been able to generate this index because it is a forecast. And we don't have the model right now to do that, unfortunately. But the forecast for this index gives us a performance of over 90%. So that is basically what we wanted to share with you all. So the model that NASA developed right now in the ozone season, we tried to use it. We could use it in some cases, not in other cases. And May which was the strongest season, we couldn't use it, but we have carried out a small evaluation of the data that we were able to get. And the performance is all right. So, and we are very glad to hear about these new stages where we will be able to adjust or train them all ourselves, because we do need to retrain them all that we send out, because it's no longer providing accurate data. And that's it. Thank you. I'd like to thank NASA as well for helping us, letting us participate in this. And thank you to the WRI as well.
Thank you so much, Monica. And I think that that is also important to know that even teams that has a lot of experience at yours, a lot of work also and years, they also struggling and facing challenges as many others. And I think that you are finding sort of ways of meeting the challenge. So thank you so much for sharing this. And we will continue with our last speaker. I would say, as you heard before from Kesia, is that in order to do I will invite Richard from airport. And I think it's important just to remind everyone that when we were doing we were evaluating the possibility of having air quality forecast for some cities in which the data is coming from local sensors network. ERCO was one of the very important partners, data partners. Now we have, as we saw with Kesia, the data from Kampala. And we would like to hear from Richard. Richard, if you can tell us, being a very important group and data partner, now that you see their quality forecast, first, how do you see this tool as a potential tool for cities? And also knowing that you have also you generate an air quality forecast based on machine learning, I guess. So if you can share with us, what is your vision? What do you think is also the challenges for cities with relatively short time generating this important data and air quality monitoring, and how a tool like the air quality forecast could help? Thank you, Richard.
Right. Thank you, Beatrice. Yes, as introduced, I'm Richard Serunjoji from Makerere University. And yeah, this is a very important topic which sits at the core of our mission, which is to collect, analyze, and forecast air quality data to international standards while working with partners to reduce air pollution and raise awareness of its effects in African cities. To go directly, I think, to the question, maybe first, what's maybe the potential forecasting tools to the cities? Yeah, I think as already maybe discussed by previous panelists, forecasting for different cities is very important for ensuring that at least the community or the policymakers are aware of what the pollution or the air quality is going to be in the future for better planning, both in short term and long term. And it is the case here in Kampala, where I'm based, but it's the same scenario in other cities where we've operated, Nairobi, Nigeria, Lagos, and other cities where we have networks. So WRI and the team, thank you for developing a tool like CanAIRy Alerts, which can support forecasting at city levels. Yeah, maybe to share a bit more on the experiences, I think, from ERCO regarding forecasts. I think we are part of the data providers for the CanAIRy Alerts, but also internally, we had like a forecasting tool already built into our products. We have it in ERCO mobile app. You can access forecasts from ERCO platforms. But yeah, to share briefly about maybe the need and the experiences, I think it is crucial, maybe one thing, to involve the communities while developing these forecasts. And I think WRI and the team has tried to do that. From AirQuest experience, I think we started with developing these forecast models for the different cities, based on literature. But then when we went to the city, to the users, we found out that maybe we started with doing hourly forecasts, like 24-hour forecasts. But then community members were asking for maybe longer term forecasts. So you have to find that balance and ensure that your tools meet what the users want, so that it is usable. So after that discovery, we integrated now both approaches, where we included the hourly forecast for those who might 24-hour forecast for those who might need short-term forecasts, and also kind of long-term forecasts, like forecasts for 7 days. We would have liked, I think, to go quite further in time, maybe like monthly forecast, 2 months forecast. But as you saw in the earlier presentation about the decline of in accuracy after a number of days, it's the same issue I think we found, and then we had to take a trade-off, and we went for at least 1 week's forecast where we could get some acceptable accuracy in terms of reporting when you compare to the actual observations. I think we've been doing this for some time, and how we evaluate our forecasts. Basically, we use some of similar metrics that have been mentioned before, the root mean square error, which tries to give difference in what the observations observed vis-a-vis the forecasts. And we do like retrain the model periodically. We have, I think, like a 1 month window where we train the models, and we keep track of the metrics using a tool called MLflow. I don't know, maybe the technical team here might be aware of it, but that's what we use to record the performance of these models. And over time, you can evaluate and see your models are improving, are you using the right models, etc, etc. And now briefly about some of the challenges I think we've encountered, and maybe some lessons that can be scaled to other cities. Of course, one challenge I think that is common or that has limited this is data availability and reliability. Of course, in Kampala, we have a unique situation where we've managed to have like this dense network, which can be used to provide data for these forecasts, but you find that sometimes still you face challenges when the network is down, yet your forecasting model require input data maybe from the previous few days, which is not available. And when you try to interpolate, you'll be getting like similar values. And I think this challenge also, I don't know whether Reynoso or Kezia, I think maybe can comment on that. I think we had data availability challenges when we were evaluating the CanAIRy Alert model here. So that's a common challenge. And also the other bigger challenge in addition to that is how to make people appreciate more, like the local people appreciate more these forecasts. Of course, we started by giving graphs, doing this, but when you interact with the people on ground, some of this information might not be making sense to them. And one takeaway or outcome that came out of that was maybe you just present these forecasts in terms of the color-coded representation of the AQI, at least without the figures. for a lay person, so that maybe if someone who is much interested like in the numbers can go like on a detailed page where they can access the values. But to someone just knowing that the air in the next 2 days or in the next hour is going to be bad or is going to be good is just enough for them to to make a decision without looking at the figures. Yeah, in summary, I think that is high-level experiences from Kampala, but we can have some maybe further one-on-one talk on the side in case anyone is interested in more information. Yeah, thank you very much, Beatrice.
And thank you for highlighting also the importance of getting in contact with the users. I think that's also an issue for CanAIRy Alert. We have been aiming at air quality managers, but as you mentioned, the importance also for general population, right, that can use the project. And with that, I will leave to my colleague, George Manicki, who will close the session today. George, please.
Thank you, Beatrice, and thank you all the presenters and all the participants. I think this was very, very exciting, and I really learned a lot, and I really appreciate that. And seated here, I was wondering if should all the research projects be like this, where the researchers are interacting with the users to kind of understand what is needed and kind of try and tailor the work they do, because I'm finding this very exciting. So the research will not just end up in a publication that maybe 10 people read, but is actually transforming lives in the cities that we are collaborating in. So that is really, really exciting. And it seems there is still a lot of work to be done to make this more perfect. And I hope we will work together to make that happen. And I really appreciate all of you for being here. And because we are running out of time, I want to just appreciate you and give it back to Anna to give us the final directions.
Thank you. Goodbye.